Then slide 16. Okay. Good morning to all of you. Today we will discuss about topic 15 of 12th standard, that is structure of atoms and nuclei. Okay. What is the development in order to know the structure of atoms and nuclei? The theory part we will finish first, and after that we will solve number of problems based on this topic. The journey starts from the first one, that is Eusebius and Democritus. What he says, every matter is made up of individual particles called as atoms. Okay. After that, Dalton's theory, matter is made up of indestructible particles. Atoms of given element are identical. Combination of atoms form new substance. After that, we will discuss about J.J. Thomson's atomic model, Ernest Rutherford's atomic model, and Niels Bohr's atomic model. Okay, and after that, we'll discuss about the problems based on all these three models. The first one, Thomson's atomic model. If voltage is applied across cathode and anode in a discharge tube, then electrons are emitted by the cathode. Then, as per Plum-Pudding model of atom is positively charged sphere in which negatively charged electrons are embedded. Okay. In atom, the total positive charge is equal to total negative charge. Okay. Next, Geiger-Madsen experiment. This is the diagrammatic representation. Source of alpha particle, when alpha particles are going to be incident on a thin metal foil, then scattering of the alpha particles is taking place. So observations, most of alpha particles passes through gold foil without deviation. Few alpha particles are reflected through various angles. Very few are reflected back from gold foil. These are the observation. And after that, this Rutherford's atomic model was born, right? When alpha particles are going to be incident on a gold foil and scattering of these alpha particles takes place. But the observations are there. Most of alpha particles passes through gold foil without deviation. Few alpha particles are reflected through various angles, and very few are reflected back from gold foil. And as per this observation, Rutherford's atomic model was born. Every atom consists of positively charged core called as nucleus. Total mass and positive charge of atom is confined in the nucleus. The negatively charged electrons are revolving around the nucleus in circular orbits. The total positive charge on nucleus is equal to total negative charge on revolving electrons. Unless and until you are you are known with uh, some basic part, you could not be able to solve the number of problems. That's why I'm passing this concept. So, what is the Rutherford atomic model? He has defined for the nucleus, and his negative, he said that negatively charged electrons are revolving around the nucleus in circular orbits. The total positive charge on nucleus is equal to the total negative charge on revolving electrons. The size of nucleus is very small as compared to size of atom. Then why the development has been taken place? In order to define the structure of atom, he has put forward these particular observations and research. But in order to give the support, some limitations are occurring. It could not explain stability of atom. not explain origin of spectral lines. And that's why Bohr's atomic model was born. The electrons revolves around the nucleus in circular orbits. The concept of circular orbit have been put forwarded by Rutherford. Okay, the electrons revolves around the nucleus in circular orbits, where centripetal force of acceleration is to be balanced by the electrostatic force of attraction. Okay, the electrons revolve around the nucleus in circular orbits by following this concept that centripetal force of acceleration required to revolve the electrons in different orbits is to be expressed in terms of electrostatic force of attraction in between electrons and the positively charged particles. The next hypothesis, the radius of orbit of an electron can only take certain fixed values such that the angular momentum of electrons in these orbits is an integral multiple of h upon 2 pi. The electrons can revolve in those stationary orbits. Electrons can revolve in those stationary orbits, okay, where angular momentum of an electron is completely balanced by this nh upon 2 pi, integral multiple of h upon 2 pi. The radius of orbit of an electron can only take certain fixed values such that angular momentum of electrons in these orbits is an integral multiple of h upon 2 pi. You have to remember all these formulas, please note it. Then electrons can make transition from one its orbit to another orbit having lower energy. Here it emits a photon of energy equal to difference between energies of two orbits. Okay. As per Bohr's third postulate, when an electron jumps from higher energy orbit to lower energy orbit, it emits the radiations. It emits a photon of energy equal to difference between energies of two orbits. Now all these formulas are important in order to solve the example. You just go on noting these formulas. So how to calculate the radius of stationary orbits? Which orbits are stationary? Where electrons are just revolving in those orbits, which follows the condition that angular momentum of an electron is equal to an integral multiple of h upon 2 pi. So by using Bohr's theory, we have what we have, angular momentum equals to h upon 2 pi. Okay, so as per Bohr's first postulate, we have centripetal force of acceleration equals to electrostatic force of attraction in between electrons, revolving electrons, and positively charged particles. Then from above equations, we have what we are getting, m n square h square upon 4 pi square m e square r cube of n. Okay, so equals to z e square upon 4 pi epsilon 0 r square, radius of nth orbit and square of that. Okay, so by referring these equations, we have studied how to obtain the equation for radius of an atom. We are not going in detail for derivations, as it's not required. Only you should know the formula and basic words from this topic. Radius of nth orbit equals to n square h square epsilon 0 upon pi m e z e square. n square h square epsilon 0 upon pi mass of electron. Here radius of nth orbit, n square, that is n is principal quantum number, h is Planck's constant, epsilon 0 is permittivity of free space, pi constant, m mass of electron revolving in stationary orbits, of which The value is given by 9.1 into 10 raised to minus 31 kg. Z is atomic number and E charge on charged particles square root n. Here, radius of Bohr's orbit is directly proportional to square of principal quantum number. Okay, that means radius of nth orbit is directly proportional to n square. Next one, energy of the electrons. How it can be calculated? As we know that we have calculated the equation for radius. You please remember which is the equation: n square h square epsilon 0 upon pi m e z is. Now focus on energy of the electrons. The total energy of an orbiting electron is the sum of its kinetic energy and its electrostatic potential energy. Thus, energy of electron revolving n orbit equals to kinetic energy plus potential energy. En being the total energy of electron in nth orbit. This is kinetic energy, this one is potential energy. So what we are having, z square e raised to 4 into mass of electron upon 8 h square n square epsilon 0. M mass of electron z square e raised to 4 upon 8 epsilon 0 n square h square. This is very famous equation where we are discussed that energy of an electron orbiting in nth orbit is directly proportional to 1 upon n square. The ionization energy of an atom is the minimum amount of energy required to be given to an electron in ground state of that atom. The ionization energy, there are two concepts: binding energy and ionization energy. Ionization energy of an atom is the minimum amount of energy required to be given to an electron in ground state of that atom to set the electron free. Means in order to have the transition to jump into space, we should have to provide the amount of energy in the form of photons. So the ionization energy of an atom is the minimum amount of energy required to be given to an electron in ground state of that atom to set the electron free. It is the binding energy of the hydrogen atom where Z equals to 1. Okay? So here is the energy level diagram. Okay? We can here with this particular diagram to solve the number of problems. Okay? So this is the energy level and transition between them for hydrogen atom. This energy is not up to the scale. Only we are limiting this as the energy difference for E1, E2 is greater as compared to the further differences. For n equals to 1, for hydrogen atom, let me clear the things that why these spectral lines are occurring. Why these spectral lines are occurring? That it says that when an electron jumps from higher energy orbit to lower energy orbit, when an electron jumps from higher energy orbit to lower energy orbit, it emits the photons. It emits the radiations. Okay, and due to those radiations, we are getting these spectral lines. When the transition of an atom takes place from higher orbits corresponding to n equals to 2, 3, 4, 5, n equals to infinity, up to or on to this even state, then we are getting Riemann series. Riemann series, Balmer series, Paschen series, bracket and Fund series, where the transition is taken place from higher stationary orbits into lower stationary orbits respectively on E1, E2, E3, E4 and so on. Means the transition from higher energy orbits is taken place onto this E1 energy state. It creates Lehman series. In the transition of an atom from n equals to 3, n equals to 4, n equals to 5, etc., jumps into n equals to 2 state, where the energy is calculated as minus 3.4 electron volt. Like that, the partial series is observed. Partial series is going to produce when the transition of an electron from n equals to 4, 5, 6, 7 is taken place to occupy the ground state as the energy state of n equals to 3, where the energy is minus 1.51 electron volt. Okay. So this is called energy level diagram for hydrogen atom. Next one. Then again, there are some limitations of Bohr's model. What are those? It could not explain the line speed of the atoms other than hydrogen. म्हणजे आपण Lehman series, partial series, bracket series, quant series ह्या सगळ्या स्पेक्ट्रल लाईन्स त्या बोर्स थिअरीनुसार एक्सप्लेन करू शकतो. पण अदर दॅन हायड्रोजन ॲटमच्या ज्या काही स्पेक्ट्रल लाईन्स होत्या त्या आपण तिथे एक्सप्लेन करू शकत नव्हतो. Even for hydrogen, more accurate study of Oxford spectra showed multiple components in some lines which could not be explained on the basis of this model. Okay, this is the first limitation. Next one, intensity of the emission lines seem to differ from liner to liner, and Bohr's model has no explanation for that. Okay, ठीक है. On theoretical side also, the model was not entirely satisfactory, as it arbitrarily assumed orbits following a particular condition to be stable. There was no theoretical basis for that assumption. Then after that, they probably put forward the concept of matter waves that already we have discussed with. They probably suggested that instead of considering the orbiting electron inside the atom as particles, we should view them as static waves. The concept of static wave has been given by De Broglie. As light has dual nature, material particles also should have dual nature, that is, wave and particle. That is, the concept we have explained as dual nature of radiation and matter. Okay. Since in order to explain reflection, refraction, diffraction, polarization, we are uh, considering the wave nature of light. Whereas in order to explain the concept of photoelectric effect, quantum effect, we should have to support for the particle nature observed in light waves. That means it exhibits dual nature. On similar basis, if we are saying that nature follows symmetry, nature loves symmetry, as the radiation and matter are only the two entities observed in the universe. If the light is following, radiation is following dual nature, then obviously matter should exhibit dual nature. And where wavelength of De Broglie wave is given by 2 pi r equals to n lambda. 2 pi r equals to n lambda. If n equals to 1, 2 pi r equals to lambda. n equals to 1, 2, 3, evening, lambda equals to 2 pi, radius of an atom orbiting in nth orbit upon n. Okay? The relation between d Broglie length and linear momentum is given by lambda equals to h upon p. P of an electron, P of an atom revolving in nth orbit, okay, equals to h upon mv. What is P? P is the momentum of an electron. From equation 1, what we have? So, momentum of an electron which is in motion must be equals to nh upon 2 pi r. And the same Bohr has put forward it before the tip of the equation. And here is the coincidence that momentum P equals to nh upon 2 pi r. Angular momentum of an electron in nth orbit is given by angular momentum of an electron in nth orbit is given by this momentum of an electron in nth orbit into radius. NCR. What is linear momentum? Linear momentum is m into v, that is mass into velocity, and mvr is nothing but angular momentum equals to nh upon 2 pi. Sometimes it is to be denoted as required in the formula, that n h upon 2 pi equals to L omega, okay, which is nothing but second postulate of Bohr's atomic model. So this is the standing electron wave for the fourth orbit of an electron in an atom. Now the concept of atomic nucleus. What is that? Constituents of the nucleus. Atomic nucleus is made up of subatomic particles called protons and neutrons. Together, they are called nucleons. Okay. Mass of proton is about 1836 times that of an electron. Mass of neutron is near the same as mass of proton, but slightly greater than mass of proton. Proton is positively charged with magnitude of charge is same as magnitude of charge of an electron. Proton is having same charge like the charge on an electron. What about mass? Mass of proton is 1836 times that of electron. Okay. Neutron is electrically neutral because charge on both is same. Proton is positively charged, electron is negatively charged. That's only the difference. The number of protons in an atom is called atomic number and designated as Z. Number of neutrons is denoted by capital N. The number of protons in an atom is called its atomic number and designated as Z. Okay. The total number of nucleons means what? Nucleons consist of protons and neutrons. Nucleons. So the total number of nucleons in a nucleus is called mass number. What is atomic number? The protons in an atom is called atomic number. Okay. And what is mass number? Mass number is total number of nucleons in a nucleus and denoted by A equals to Z plus capital N. Therefore, means mass number equals to atomic number plus number of neutrons. Okay. Therefore, atom of an element is denoted by A, that is mass number, Z, that atomic number, and that element. Element is having, let us suppose, 2He4, helium 2He4, consider a cell. Here it is given. 1H1 means this one is atomic number, this one is mass number. This is atomic number, this is mass number. This is atomic number, this one is mass number. Okay. The chemical properties of an atom is decided by number of electrons present in it. That is atomic number. Am I audible? Okay. The next point, isotopes, isobars, isotones. Atoms having same number of protons but different number of neutrons are called isotopes. Examples are given. Atoms having same number of protons but different number of neutrons are called as isotopes. Example, deuterium, tritium are isotopes of each hydrogen. Hydrogen is 1H1. Isotopes are deuterium, tritium, where this mass number is same. Okay. So, okay. Next one, 2He3. This Z is same for both. Number of protons. Z is same for both. Okay. But mass number is different due to the number of neutrons present in that nucleus. So 2He3, 2He4 are the isotopes. Next one, isobars. The atoms having same number, same mass number A are called isobars. Examples, isotopes म्हणजे काय, तर त्याच्यामध्ये सेम नंबर ऑफ प्रोटॉन्स असतात, झेडची व्हॅल्यू सेम असते पण मास नंबर इज डिफरंट. पण त्या आयसोबार्समध्ये काय असतं तर मास नंबर हा सेम असतो, एची व्हॅल्यू सेम असते पण झेडची व्हॅल्यू मात्र डिफरंट असते. ठीक आहे, यू रिमेंबर. नेक्स्ट वन, आयसोटोन्स. Atoms having same number of neutrons with different values of atomic number are called isotones. What you are observing here, 1H3 and 2He4 are isotones. Atoms having same number of neutrons. Neutrons की संख्या same असते, but different values of atomic number. Atomic number is different. म्हणजे इथे at least mass number same आहे, इथे काय आहे ॲटॉमिक नंबर सेम आहे, पण इथे मात्र काय होतं तर मास नंबर पण डिफरंट आहे आणि ॲटॉमिक नंबर पण डिफरंट आहे, बिकॉज सेम नंबर ऑफ न्यूट्रॉन्स असतात बट डिफरंट व्हॅल्यूज ऑफ झेड आर कॉल्ड आयसोटोन्स. नेक्स्ट वन, युनिट्स फॉर मेजरिंग मासेस ऑफ ॲटॉम्स. आता हे सगळे केजीचं कन्व्हर्जन ग्रॅम्समध्ये कसं करायचं किंवा चार्ज तसाच ठेवायचा का वगैरे वगैरे हे सगळं तुम्हाला माहीत असणं गरजेचं आहे. तर तुमचे एक्झाम्पल्स ही फार पटकन सॉल्व्ह करून घेतात. युनिट्स फॉर मेजरिंग मासेस ऑफ ॲटम्स इन सबॲटॉमिक पार्टिकल्स. There are three different units of measurement of masses. The first one, mass of an electron. First unit is usually kg. In this system, mass of electron, proton, neutrons, mass of electron, proton, neutron, respectively, are mass of electron. Its standard value we are considering, we are converting 0 time in terms of 1, okay, and the value we are taking as 9.11. Mass of electron is 9.11 into 10 raised to minus 31 kg. Okay. Mass of proton 1.6726, that we are discussing as 1.67. Okay. 67 into 10 raised to minus 27 kg. Mass of neutron is 1.67. This 9 we have converted into, this 4 has to get converted into 5. So 1.675 1.675 into 10 raised to minus 27 kg. Kg is not convenient method for measurement of masses of subatomic particles. Therefore, another unit called the unified atomic mass unit. Atomic mass unit is used. What is unified atomic mass unit? One atomic mass unit is equal to 1 by 12th of mass of neutral carbon having atomic number 12 in its lowest energy state. Okay. One atomic unit is equal to 1 by 12. Take the reference घेतली ना की mass of neutral carbon atomच्या 12 percentage means 1 Armstrong unit is equal to 1 by 12 of mass of neutral carbon atom having atomic number 12 in its lowest atomic state. And if you are calculating, that value is coming as another reference one change. So one atomic mass unit equals to 1.66 into 10 raised to minus 27 kg. In this unit, the masses of above three particles are expressed most frequently in order to solve the example we are using. You are most familiar with this substitution that mass of an electron is 9.11 into 10 raised to minus 31 kg. Mass of electron is 0.00055. Means this value you have converted in terms of one atomic mass unit. Okay. So mass of proton is also discussed. Mass of neutron by having the conversion parameter you are getting. Next one, the third unit is in terms of amount of energy that their masses are equivalent to. The unit used for measurement of masses is electron volt per c square. What is c? C is the velocity of light. In terms of velocity of light, we have expressed one atomic mass unit equals to 931.5 million electron volt per c square. Okay. So the masses of three particles in this unit are mass of electron 0.5 million electron volt per c square, mass of proton 938.28 million electron volt per c square, mass of neutron is 939.57 million electron volt per c square. Now the next concept is that size of nucleus. The size of the nucleus depends on number of neutrons present in it. That is, on its atomic number A. From experimental observations, it is found that radius of a nucleus is related to A by this formula. How to determine size of nucleus? Nucleus consists of nucleons, that is number of protons plus number of neutrons. The size of nucleus depends on number of nucleons present on it. It's a direct proportional to on its atomic number 2. From experimental observations, it is found that Rx of a nucleus X is denoted related to A as radius of a nucleus is given by R0 into A raised to 1/3. Okay. Means R is directly proportional to A raised to 1/3. What is A? A is the atomic number. Okay. Next, where R0 equals to 1.2 into 10 raised to minus 15 meter. The density rho inside the nucleus as the as the nucleus is spherical in nature, we are calling density rho inside the nucleus is given by 4 by 3 pi r cube into rho equals to mass into atomic number, where m is average mass of nucleus, density is given by density equals to 3ma upon 4 pi into r cube present in nucleus X. Okay. Putting the value of radius of a nucleus of element X is given by rho equals to 3m upon 4 pi r cube equals to constant. Thus, density of a nucleus does not depend on atomic number of the nucleus and is the same for all nuclei. The value of nuclear density is rho equals to 2.3 into 10 raised to 17 kg per meter cube. Then the concept of nuclear forces. Out of these four, there are four different forces. Out of these four different forces, the force that determines the structure of the nucleus is the strong force. That determines the structure of the nucleus is the strong force, also called nuclear force. This acts between proton and neutron and mostly attractive properties. It is the strongest force among subatomic particles. Its strength is 50 to 60 times larger than that of electrostatic force of attraction. The nuclear force has a range of about a few Fm Faraday meter, and the force is negligible when two nucleons are separated by larger distance. Nuclear force is independent of the charge of the nucleons. Okay. Then next one, the concept of nuclear binding energy. Amount of energy required to separate the nucleons from each other and take them to a large distance is called binding energy. Binding energy is given by delta mc square, as we know the very famous equation, Einstein's equation for mass particle duality or law of conservation of mass and energy. Binding energy is E equals to mc square. So what is delta? That is delta m is mass defect. Delta m is mass defect. Amount of energy required to separate the nucleons from each other and take them to a large distance is called binding energy. Thus, binding energy is expressed in terms of mass defect. So, the delta n is called mass defect and given by formula delta m equals to z into mass of proton plus n into mass of neutron minus capital M. What is z? Z is the number of protons, n is number of neutrons, and m is the mass of the nucleon. Okay. Here Z is atomic number, n is neutron number, mass is mass of proton, n is mass of proton, and mn mass of neutron. And by that you will be able to find the mass defect. And by using this mass defect, you will be able to find the binding energy. This is the graphical representation. If you are plotting the graph in between binding energy for nucleon as a function of mass number, then some magical numbers you are getting. Okay. So here we are defined bending energy of hydrogen nucleus having a single proton is zero. Okay. This point you have to remember. Next one, radioactive decay. Many of the nuclei are stable. This is the new concept. That is how the disintegration of the nucleus, nucleons is taking place. Many of the nuclei are stable. That is, they can remain unchanged for a very long time. Many of the nuclei are stable. The concept of stability of the nucleons was not able to explain by Bohr's theory of hydrogen atom, but here we are trying to make it simple. So radioactive decays, many of the nuclei are stable, that is they can remain unchanged for a very long time. Other nuclei occurring in nature are not stable and undergo changes in their structure by emission of some particles. The change or decay to other nuclei in the process. The decaying nucleus is called parent nucleus, while the nucleus produced after the decay is called the daughter nucleus. The process is called radioactive decay or radioactivity. Radioactivity is simply the spontaneous emission of the radiations, such as alpha particles, beta particles, and gamma rays. Okay, so there are three decays. Alpha decay. What we said, radioactivity, there is spontaneous emission of alpha particles, beta particles, and gamma rays from the nucleus is taking place. So the concept of alpha decay in this type of decay, the parent nucleus emits an alpha particle, which is the nucleus of helium atom. The parent nucleus thus loses two protons and two neutrons. The decay can be expressed in terms of it is the element with proton number Z, mass number A. Okay, so it is for what it said during the alpha decay process, it loses two protons, Z minus 2. It loses two protons and two neutrons. A is number of protons plus number of neutrons, but here two neutrons are to be lost and plus one of the alpha particle is emitted, and that alpha particle we are saying as 2He4 because two protons and four neutrons, 2He4. So when the spontaneous emission of bismuth Pi is taking place having atomic number 83 and mass number is 2 and 2, then we'll be getting new radioactive element as Pl, helium. Okay, so having atomic number as 81 and mass number is 208 plus one of the alpha particle is emitted. The total mass of the product of an alpha decay is always less than the mass of parent atom. The excess mass appears as the kinetic energy of the product. The difference in the equivalent of the mass of parent atom and that of sum of masses of the product is called Q value. Q value of the decay is equal to kinetic energy of the products and can be written as Q equals to mx minus my minus mhe 2he4 into c square. Okay, so mx, my, and mhe are the masses of parent atom, the daughter atom, and the helium atom. Because during alpha decay process, one of the helium atom in the form of 2He4 is going to be emitted. So we have to discuss about the mass of helium atom, mass of daughter atom, and mass of parent atom. So that will provide you the Q value. Okay. Now, what happens when beta decay takes place? The beta particles are emitted from the nucleus and how it affects on it. So, one of the electron is going to be emitted. In this type of decay, the nucleus emits an electron produced by converting a neutron in the nucleus into a proton. म्हणजे एक इलेक्ट्रॉन इथे emit होतो. In this type of decay, the nucleus emits an electron produced by converting a neutron in the nucleus into a proton. आता न्यूट्रॉनला जर प्रोटॉनमध्ये कन्वर्ट करायचं असेल तर आपल्याला आणि एक इलेक्ट्रॉन बाहेर ठेवावा लागतो. The basic process which takes place inside the parent nucleus is N neutron converts into proton plus one of the electron plus anti-neutrino. Okay? Neutrino and anti-neutrino are the particles which have very little mass and had no change. In beta decay, there is no change in mass number, but atomic number is increased by 1. Okay. So, here is this element having Z value, and this is mass number. Z plus number of neutrons is equal to E. So, it provides you Z plus 1, एक electron emit होतो, एक. So, we are getting Z plus 1 and this the neutron element plus anti-neutrino. An example is 27 cobalt 16. 27 cobalt 16. Z value 27, H value 16. त्या केसमध्ये एक इलेक्ट्रॉन त्या ठिकाणी एक प्रोटॉन ऍड होतोय. Neutron is going to be converted into proton, and plus one electron is going to be emitted. That's why this Z number is increased by 1 plus anti-neutrino. There is another type of beta decay called beta plus decay. Okay, so this the exchange of proton into neutron. In this process, mass number remains unchanged. Mass number remains unchanged during the decay, but atomic number decreases by 1. और रियर केसमध्ये atomic number हा एकने वाढून राहतो, पण एक मात्र काय होतं तर मास नंबर हा सेम राहतोय, पण atomic number मात्र एकने डिक्रीज होतो. न्यूट्रॉन नंबर increases by 1. So these are some radioactive decays. Here is third decay, there is gamma decay. In this type of decay, gamma rays are emitted. Alpha particles, beta particles, but gamma rays. Okay. In this type of decay, gamma rays are emitted by parent nucleus. Gamma rays are high energy photons. The daughter nucleus is same as parent nucleus, as no other particles are emitted, but it has less energy, as some energy goes out in the form of emitted gamma rays. Similar to the electrons, the nucleons occupy energy levels with different energies in nucleus. A nucleon can make a transition from higher energy level to a lower energy level, emitting a photon in this process. The energy difference in atom is of few electron volts, but for nucleus this difference is of few kilo electron volts, as in terms of millions of electron volts. So we are seeing few electron volts. Okay. So it needs to be there for gamma rays. Gamma rays से जो मैं emission होता है, तो G energy से बाहर होते. It is not simply in few kilo electron volts, but it leads to have the conversion parameter in terms of million electron volts. Therefore, radiations emitted by the atom are in the ultraviolet to radio region. The radiations emitted in nuclear are in the range of gamma rays. Usually, gamma rays occur after alpha or beta decay because gamma rays requires large amount of energy for excitation of nucleus. A nucleon end up in an excited state as a result of planet nucleus undergoing alpha or beta decay. Okay, here is one of the example. Next, please formulate your number by solving at least we'll discuss at least one type of problem based on all the theory we have, we have seen. So, law of radioactive decay. At any instant, the rate of radioactive disintegration, how the radioactive decay is governed by. That is given by law of radioactive decay. At any instant, at any time, the rate of radioactive disintegration is directly proportional to number of nuclei of the radioactive element present at that instant. The rate of radioactive disintegration means the rate of radioactive disintegration Dn by d is proportional to number of nuclei of the radioactive element present at that instant. It is to be expressed in terms of n0. Okay? The basic law is dn by d equals to minus lambda into capital N, where this minus lambda is the proportionality constant. Why it is there? From the law of radioactive decay, dn by dt. dn by dt. Here we are getting some correction. dn by dt. What is that? Rate of change of disintegration of the nucleus dn by dt is directly proportional to n. That's it. Okay, here also P should be here. And that proportionality constant is given by this lambda. So we can just rearrange the terms we are getting. dn by n equals to minus lambda into dt. This p goes to that side. Okay? Where lambda is a constant of proportionality, which is also called decay constant. Right? So lambda is a constant of proportionality called the radioactive decay constant or the disintegration constant. It is a constant for a particular radioactive element. It is different for different elements, obviously. Okay. The minus sign indicates that n decreases as t increases. n decreases as t म्हणजे जेव्हा रेडिएटिव्ह डिसइंटिग्रेशन होत असते तेव्हा त्याच्यामध्ये n काय असतो n is the number of nuclei present at any time t. जसं टाइम चेंज होतो टाइम इन्क्रीज होतो त्यावेळेस डिसइंटिग्रेशन सॉरी n ची व्हॅल्यू ही कमी कमी होत जाते. ठीक आहे. So rate of change of radioactive decay is directly proportional to number of nuclei present at any time or at the time of disintegration. So it is governed by the very fundamental equation n upon n0 equals to e raised to minus lambda into t. What is n0? N0 is the number of nuclei present at any time t. At t equals to 0 means at initial stage when the time when the radioactive decay process is not started. So n0 is the number of nuclei present at any time equals to 0, and after the disintegration taken place at the particular time t, then at that time what is the n number of nuclei present, and it is to be expressed with original number n upon n0 equals to e raised to minus lambda into t. Is the time at which we are going to calculate the number of nuclei present in the nucleus. So it is given by n equals to n0 e raised to minus lambda into t. This is the exponential form for the law of radioactive decay. It shows that number of nuclei present decreases exponentially with time. Next. How to calculate the activity of radioactive element? आता ही ऍक्टिव्हिटी ऑफ रेडिएक्टिव्ह एलिमेंट म्हणजे काय हा प्रश्न. तर ऍक्टिव्हिटी ऑफ अ रेडिएक्टिव्ह एलिमेंट इज इक्वल टू इट्स रेट ऑफ disintegration, not designation. Here is one typographical error, that is, this must be the activity of a radioactive element is equal to its rate of disintegration. In other words, we can say that number of decays per unit time is called its activity. It is different for different nucleus, obviously. Number of decays per unit time is called activity. Okay, the activity of a radioactive element is equal to its rate of disintegration. Number of decays per unit time. Number of decays per unit time is called the activity. It is here. Next, and is given one. Activity equals to minus dn by dt. Why the minus sign is appearing here? As we said that as the time increases, the rate of disintegration decreases. N number values decreased. Okay, so activity of the sample. Just now we have defined in terms of n number of nuclei present. How we have defined this relation of radioactive decay? That is simply n equals to n0 e raised to minus lambda into n. On similar strategy, we can find a equals to a0 e raised to minus lambda into 3. I put it. So activity of the sample is to be expressed, activity at any entity is to be expressed in terms of activity at the initial stage into this as the decay constant. This decay constant is to be expressed in one of the formula that we will see. Okay, so its SI unit is backward. Activity needs to be expressed in terms of A equals to A0 e raised to minus lambda t, and its SI unit is backward. Disintegration per time, number of decays per unit time is the activity. And 1 Curie becquerel is very short unit, so it is to be converted in terms of Curie, and that Curie conversion is 3.7 into 10 raised to 10 becquerel. 3.7 into 10 raised to 10 becquerel equals to 1 Curie. What is becquerel? Becquerel is decay per second. 1 decay per second, 1 becquerel. So 3.7 into 10 raised to 10 becquerel equals to 1 Curie. And again, it has to be converted in one more unit, that is 1 to the 4th. 1 to the 4th equals to 10 raised to 6 decays per second. So more frequently used this unit of activity is Curie. Remember, you should know this particular conversion parameter. Next one, how to calculate half-life of radioactive material. The time taken, this again new concept actually. कोविड-19च्या सिलेबसला हा पोर्शन डिलीट केलेला होता, पण आता तो परत आपल्याला इथे स्टडी, आपण थिअरीसाठी स्टडी केलेलाच नाही, पण आता CET-साठी सुद्धा ह्याच्यावरती प्रॉब्लेम्स आहेत. ठीक आहे, सो वी हॅव टू डिस्कस ऑन दिस. हाफ लाईफ टाईम, एखाद्या एलिमेंटचा हाफ लाईफ म्हणजे ओरिजिनल न्यूक्लियनची संख्या हा होण्यासाठी टाइम किती घेतला जातो त्याला म्हणतात हाफ लाईफ टाइम. ओके, एखाद्या एलिमेंटमध्ये ओरिजिनल न्यूक्लियर एन इतके असतील आणि त्यांचा हाफ डिसइंटिग्रेशन होण्यासाठी लागलेला टाइम म्हणजे काय तर half life of radioactive material. The time taken for number of parent radioactive nuclei of a particular species to reduce to half of its value is called half-life. Half-life of the element, half-life of the species. Okay, time taken for number of parent radioactive nuclei of a particular species to reduce to half of its values is called half-life time. How it is designated T to have the disintegration to half of its original number of nuclei. Okay, so it has to express in terms of this expression. Number of nuclei at any time t equals to number of nuclei at its original time, that is at t equals to 0 into e raised to minus lambda t. So after having derivation, substitution, you are getting equation that e raised to lambda t half is to be substituted by t half. Here the substitution is there. T is to be replaced by t half into lambda. How this NT by N0, NT by N0. म्हणजे ओरिजिनल न्यूक्लियर N0 त्यांना हाफ इक्वल डिसइंटिग्रेशन करायचं असेल तर लागलेला टाइम ह्या इक्वेशन देतात. सो इट इज गिवन बाय टी हाफ. म्हणजे मोस्ट ऑफ द एक्झाम्पल्समध्ये तुम्हाला हाफ लाईफ टाईम दिलेला असतो. Disintegration constant change value are proportional to the half life and change होतो. And that constant of proportionality or T half is to be expressed in terms of 0.693 upon lambda. So thereby will be able to calculate either of the value if the lambda is given for that element, then we are able to find the value of T half. Okay. In the half-life time, म्हणजे हे सगळे बेसिक फीचर्स जर तुम्हाला माहिती असतील तर तुम्हाला डेटा सॉर्ट करता येतो. आणि डेटा सॉर्ट केला आणि फॉर्म्युला माहीत असला की डायरेक्टली तुम्ही सबस्टिट्यूशन करून तुम्हाला रिक्वायर्ड आन्सर मिळू शकतो. ओके, सो दॅट्स वाय इट्स बेसिक फीचर्स यू शुड नो. इन द हाफ लाईफ is that even though the number goes down from n0 to n0 by 2 in time t raised to half, after another time interval of t half, the number of current nuclei will not go to 0. Okay, परत परत त्यांचं डिसइंटिग्रेशन होत राहतं by following this particular law, that is t half म्हणजे n0 get converted, N0 परत मग त्याचे हाफ झाले, परत त्याचे हाफ झाले, परत त्याचे हाफ झाले. Till that value is not go to 0 in another t half. It will go to half of the value at t equals to t half, that is to N0 by 4, thus in a time interval equal to half life. The number of current nuclei reduces by a factor of half. Next one, average life of radioactive series. Just understand this formula that average life or mean life or mean life of radioactive element is the ratio of total lifetime of all the atoms and total number of atoms present initially in the sample. The number of nuclei decaying between time t and t plus dt is given by lambda into n0 e raised to minus lambda dt. The lifetime of these nuclei is t. Thus, the average lifetime of nucleus is to be expressed in terms of t, that is average life of radioactive species log 2 equals 2.693 t. What is This tau we are saying instead of T we are saying. This is T half. That is what? That is half lifetime. What is tau? This tau. Tau is average lifetime. Okay. So this must be done. Then the concept of your nuclear energy. We have seen for nuclear force. Now we are discussing for nuclear energy. Nuclear energy is the energy released when nuclei undergo a nuclear reaction. That is, when one nucleus or a pair of nuclei, due to their interaction, undergo a change in their structure, resulting in a new nucleus and generating energy in the process. Okay, we can obtain nuclear energy by two other processes, that is nuclear fission and nuclear fusion. Okay, what is the basic difference in fission reaction and fusion reaction? You will get an idea. Fission, that means disintegration into large number of atoms, large number of nucleus. Heavy nucleus, heavy nucleus is broken into two nuclei of smaller masses. huh? And nuclear fusion in which two light nuclei undergoes nuclear reactions and fuse together to form heavier nucleus. Okay, disintegration into two nuclei is nuclear fission. Two nuclei after nuclear reaction forms a heavier nucleus, that is called nuclear fusion. Next one, nuclear fission. The process of splitting of, just now we said that, the process of splitting of a heavy nucleus into two or more lighter nuclei is called nuclear fission. When a slow-moving neutron strikes with the uranium nucleus, 22 uranium-235, it splits into 56 barium 141 and 36 krypton 92, along with 3 neutrons and a lot of energy. This phenomena means this is simply, for example, so many radioactive nucleus. Um, there are 4 different series: uranium series, neptunium series, plutonium series. Okay, so these are um, 4 not 4 uranium, neptunium, plutonium, and one more series that is not there for the study, although I'm telling. So as per that, when a slow movement neutron strike with the uranium nucleus, it undergoes the fission process. Nuclear fission, the process of combining of two lighter nuclei. The process of combining of two lighter nuclei to form one heavy nucleus is called nuclear fusion. In this process, a large amount of energy is released. Nuclear fusion takes place at very high temperature, approximately about 10⁷ K. Okay, and at very high pressure of the order of 10⁶ atmosphere. Hydrogen bomb is based on nuclear fusion. Uranium nuclear reactor. A nuclear reactor is an apparatus or a device in which nuclear fission is carried out in a controlled manner to produce energy in the form of heat, which is then converted into electricity. Okay, so due to the fission reaction, we can create enormous amount of electrical energy, which is also called nuclear energy. And that nuclear needs to be used in our day-to-day life. Nuclear reactor is an apparatus or a device in which nuclear fission is carried out in a controlled manner to produce energy in the form of heat. In nuclear reactor, 92 uranium-235 is used as the fuel. It is bombarded by slow neutrons to produce 92 uranium-236, which undergoes fission. Nuclear chain reaction, if the particles starting from nuclear fission reaction is produced as a product and further take part in the nuclear fission reaction, then a chain of fission reaction started, which is called nuclear chain reaction. Nuclear chain reaction are of two types. The first one, controlled chain reaction, second one, uncontrolled chain reaction. So here are some samples of the question MCQs. The first one, rate of disintegration of radioactive nucleus. Whatever the theory you have studied, as per that, you should be able to solve these 5 MCQs in a very easy manner. The first one, rate of disintegration of radioactive nucleus is affected by temperature, pressure, external electric or magnetic field, none of the above. Rate of disintegration of radioactive nucleus is rate of radioactive nucleus is directly proportional to, which is that parameter that is dN by dt is n. dN by dt is directly proportional to n and t. This t is the time required. Okay, just check that. Here, what is that? dN by dt is directly proportional to n. That is it. What is n? N is number of nuclei present at any time t. Okay, so on that you can just get answer. Rate of disintegration. Rate of disintegration of radioactive nucleus is affected by temperature, no. Pressure, no. External electric or magnetic field, no. On which parameter it depends on? It depends on n at any time t. That is it. This is time. Okay. So what is the correct answer? That is the correct answer. Let us check here. This is the answer is B. So the correct answer is this. Next one, in a radioactive decay, only charged material particles are emitted, only energy is emitted, charged material particles as well as energy is emitted, or nothing is emitted. Radioactive decay मध्ये number of nuclei म्हणजे अल्फा पार्टिकल्स एमिट होतात, बीटा पार्टिकल्स एमिट होतात, गॅमा रेज एमिट होतात. म्हणजे फक्त चार्ज मटेरियल पार्टिकल्स हेच एमिट होत नाही, फक्त एनर्जी हेच एमिट होत नाही, तर चार्ज मटेरियल पार्टिकल्स अल्फा डिके मध्ये काय होतं, 2He4 एमिट होतो. 2He4 म्हणजे चार्ज पार्टिकल्स पण एमिट होतात आणि एनर्जी पण एमिट होते. ठीक आहे. किंवा बीटा डिके मध्ये एक इलेक्ट्रॉन एमिट होतो. करेक्ट. एक इलेक्ट्रॉन एक एमिट होतो आणि एनर्जी पण एमिट होते. इथे फक्त एनर्जी एमिट होत नाही, एमिट होतात, ओनली चार्ज मटेरियल पार्टिकल्स आर नॉट एमिटेड. म्हणजे हा पण रॉंग आहे, हा पण रॉंग आहे, हा पण रॉंग आहे. इथे करेक्ट आन्सर आहे चार्ज मटेरियल पार्टिकल्स as well as energy is emitted. Let us check second. The answer for second, that C is the correct answer. So C is the correct answer. Here charged material particles as well as energy is emitted. That is correct one. Okay. Next one, half life of an element depends upon. आता हा T raised to half असं आपण म्हटलं. त्याचा आन्सर काय येऊ शकतं बघा. हाफ लाईफ ऑफ एन एलिमेंट डिपेंड्स ऑन original amount, external pressure, temperature, none of the above. आता half life of an element हा आपण कशाने केला, तर T half equals to 0.693 upon lambda. 0.693 upon lambda. हा फॉर्म्युला अपना कशाचा रेडिओएक्टिव्ह सॉरी हाफ लाईफ टाईमचा. सो ह्यातला कुठलाच पॅरामीटर इथे नाही आहे. करेक्ट. बघा इथे P half is this relation. P half equals to 0.693 on lambda. So this equation here written here. P half equals to 0.693 upon lambda. That means half-life of an element does not depend on original amount, external pressure, external temperature, but it depends on lambda. But it is not given here. So which one is the correct? None of the above. That is the correct answer. For 3, we are getting the 4th. That is the parameter. So this is correct one. Now fourth one. A radioactive substance has half-life for 4 days. Half-life for 4 days. Let me half किती है? तर 4 days है. Time required for 31 out of 32 of the original amount to disintegrate is. So that can solve with the help of this reaction. P half equals to 0.693 upon किती वेळ आहे? Okay. So a radioactive substance has half-life for 4 days. Time required for 31 out of 32 of the original amount to disintegrate is, that we need to calculate. P half is 4 days. Half-life for 4 days. Time required. So by using this formula, I'll show you this solved example. And fifth one, that is also based on the same formula. A radioactive element decays to 1/8 of its initial amount in 75 days. Half-life of the element is. Okay, these two examples we will solve and find the answers. The answer given is here C, 20 days. The fifth one, the answer is again C, that is 25 days. Okay, so this is all about the theory part. Now let us try to solve at least one example based on the points that we have discussed. Okay. Okay. So we have seen different atomic models. The first one, J.J. Thomson's model, second one, that is Rutherford's model, and third one, Bohr's model. Okay. So let us try to get given data. What is given? Using Bohr's quantization condition, what is the rotational energy in the second orbit for a diatomic molecule? Okay. What is rotational energy? Rotational energy is given where I is moment of inertia of a diatomic molecule and h is Planck's constant. So rotational energy equals to 1/2 I omega square. 1/2 I omega square. ठीक है. But we know that what we know L equals to NH upon 2 pi. But what is L? L is angular momentum, and that angular momentum is also expressed in terms of I omega. I omega. Okay. So if we are substituting L equals to NH upon 2 pi, then what is the expression that is for second orbit? Let us see N equals to 2, second orbit for a diatomic molecule. I equals to moment of inertia, H is Planck's constant, N equals to 2. We have I omega square. Okay. N equals to 2. N equals to I omega. L omega. Yeah. L equals to I omega, first expression. L equals to NH upon 2 pi. We can compare them so that I omega equals to NH. And okay, let's get the answers here. Okay. So we have this formula. Is that is that okay? L equals to I omega. I omega. L is what? L is angular momentum. I is moment of inertia. Omega is angular momentum. NH upon 2 pi. L equals to NH upon 2 pi means H upon 2 pi. Rotational energy half I omega square. I omega square upon 2L equals to L square upon 2L. L square upon 2I equals to H square upon pi into 1 upon 2I. Okay. L is angular momentum. I is moment of inertia. And if you are substituting L equals to H upon pi as N equals to 2, we are reaching to the expression that H square upon 2I pi square. Okay, so that's the correct answer. Next one, second. So the answer is correct. H square upon 2I pi square. Okay. Next, second example. The ratio of speed of an electron in the ground state. The ratio of speed of an electron in the ground state in the Bohr's first orbit of hydrogen atom to velocity of light c is given by h is Planck's constant, epsilon is probability of free space, and E is charge on electron. So the things on. The speed of electron in nth state of hydrogen atom is given by speed. Okay, speed equals to E square upon 2h epsilon 0 into 1 upon n meter per second. For ground state, n equals to 1. Therefore, V1 equals to E square upon 2h epsilon 0 meter per second. So V1, the speed of electron with respect to C is given by E square upon 2 epsilon 0 h into C. Okay, now let us see third example. The ratio of energies of photons produced due to transition of electron of hydrogen atom from its second to first energy level and highest energy level to second level. The ratio of energies of photons produced due to transition of electrons. When J, it follows Bohr's third postulate. When an electron jumps from higher energy orbit to lower energy orbit, then it emits the photons. The ratio of energies of photons produced due to transition of electron of hydrogen atom from its second to first energy level, n equals to 2 to n equals to 1, and highest energy level to second level is given by. What is that? Okay, that's the question. Whether it is 3s to 1, 2s to 1, or 4s to 1, or 2.5s to 1. Okay. The energy of photon is given by E equals to RHC into 1 upon n1 square minus 1 upon n2 square. This is expressed in terms of Rydberg's constant. Energy of the electron in different energy states. Energy of the electrons in different energy states is to be expressed in terms of Rydberg's constant. And h is Planck's constant, and c is the speed of light. Energy of photon is the transition is taken place from 2 to 1. That means n2 equals to 1 and n2 equals to 2. Transition is taken place from 2 to 1. n2 equals to 2, n1 equals to 1, and therefore that expression is coming as E equals to RHC. Okay.